This lesson, we're going to learn how to sketch polynomial functions. Step 1, factor the polynomials fully. Step 2, find all the x-intercepts and the y-intercept. Step 3, put the x-intercepts on the number line and identify the positive-negative intervals. The positive-negative intervals on the number line can be easily determined by using the leading coefficient and the degree of the polynomials and the order of the roots. Step 4, now we can do our sketch. Example 1, let's sketch some simple polynomials. We're going to use a chart to help us to organize the findings to sketch. Part A, we have y equals x minus 2 whole thing square. It really means x minus 2 times by x minus 2. So our leading term will be the first term of the expanded form. If we're going to expand this, we will have 1x times by 1x, which is positive 1x squared, which is our leading term. However, we're going to learn a different way to find the leading term efficiently. So our leading term will be x squared. Next, let's find the roots, which are the x-intercepts. So when you let y equals 0, then we get 0 equals x minus 2. That means x equals 2. Next, we want to find the y-intercept. That means we let x equal to 0, then we have y equals 0 minus 2 whole thing squared. That means y is going to be negative 2 squared, y is going to be 4. Now, let's put the roots on the number line, and we're going to check the positive negative sign. Since our leading coefficient is a positive 1, that means on the most right-hand side interval, it will be a positive. When we go through the root 2, because on root 2, this root has an order of 2. That means the exponent is a 2. It's an even number. That means we keep the same sign. Now, let's put the roots on the number line, and we're going to check the positive negative interval. Since our leading coefficient, which is the coefficient of the leading term, is a positive 1, that means on the most right-hand side interval, it is a positive. Then, we have to go through the root 2 to reach the next interval on the left. And root 2 is coming from this bracket that has an exponent of 2. Since the exponent is even number, then we keep the same sign. So on the left-hand side, it will be positive 2. Now we can do our sketch. First, we put the x-intercept on. Next, since we know on the left-hand side and right-hand side of the 2, it will be both positive, and the order of the root is a 2. That means it looks like a parabola at the root. So now we know our sketch will be like this. And put the arrows on. And finally, we put our y-intercept on. So where the function goes through the y-axis, we're going to label that's a 4. Part B, let's find our leading term. Our leading term will be negative times by x squared. So it will be negative x squared. And then we let y equal to 0 to find the roots. So x will be negative 2. And since there is an exponent of 2 on this bracket, so we know the order of the roots will be 2. Then we let x equal to 0 to find the y-intercept, and y-intercept will be negative 4. Now, let's put the roots on the number line, and we're going to check the positive negative sign. Since our leading coefficient is a negative 1, so on the most right-hand side interval, it will be negative. And since going through the root negative 2, the order is 2. That's an even number. That means on the left-hand side of the negative 2, it's also negative. After we have the roots and the positive negative sign, then we can do our sketch. So first, let's put our x-intercept on. Next, because I know on both sides of the root is negative, that means the graph is below the x-axis. And at negative 2, the order is 2. That means at this root, it looks like a parabola. So now we can do a sketch. And where they go through the y-axis, we label them negative 4, which is the y-intercept. Part C. Let's find our leading term. Our leading term will be x to the exponent 3. Then we let y equal to 0 to find the x. That means x value will be at 1. This is our root. Since there's an exponent of 3, so we know the order of the root is 3. We let x equals to 0 to find the y-intercept, and now we get y equals negative 1. Let's put the roots on the number line and check the positive and negative sign of each interval. On the most right-hand side interval, because the leading coefficient is a positive 1, it's positive. Therefore, we know on the most right-hand side interval, it is a positive. Then when we go through the root 1, because the order of the root is 3, it's odd number. That means we're going to switch the positive sign into a negative sign. Then we are ready to do our sketch. First, put the x-intercept on. And we know at this x-intercept, it looks like a cubic function because order is 3. And on the right-hand side of 1 is above the x-axis because it's positive. Then on the left-hand side of the 1 is below the x-axis because that's negative. So I know our sketch will be like this. And where they go to the y-axis, that's labeled the -1, which is our y-intercept. Part D, once again, let's find our leading term. Our leading term will be negative x to the exponent 3. Then we let y equal to 0 to find the x-intercept. X will be -5. Since there is an exponent of 3, so we know the order of the root is a 3. And then we let x equal to 0 to find the y-intercept. Y-intercept will be at -125. Let's put the roots on the number line. And let's check the positive negative sign. So on the right-hand side of the -5, because the leading coefficient is a negative, that means on the most right-hand side interval, it will be negative. Then when we go through the root -5, the order is 3, which is an odd number. That means we have to switch a negative into a positive when we go to the next interval. Now we are ready to do the sketch. First, put the x-intercept on. And next, we know they have to go from a negative region to go to a positive region. And when they go through the -5, it should look like a cubic function because order is 3. So now the function will look like this. And when they go through the y-axis, that y-intercept will be -125. Example 2, let's sketch some polynomial functions that have more than one factor. Once again, we're going to use a chart to help us to organize the findings in order to sketch. Part A, let's find our leading term. Our leading term can be found by multiplying the highest degree term in each of the factor, which will be x times by x times by x, which is +1 x cubed. Next, we have to find the degree of the polynomial. The degree of the polynomial is the highest exponent of the expanded form, which is the exponent of the leading term, which is a 3. Then we let y equal to 0 to find the roots. So the first one, x could be 0, and there is an exponent of 1. That means we say order 1 root. Or we say x minus 1 could be 0, which means x could be 1. Once again, there's an exponent 1 here, so we say order is 1. Or x plus 2 equals to 0 means x could be -2. And once again, the exponent here is invisible 1, so we say that's order 1 root. Next, we let x equal to 0 to find the y-intercept, and the y-intercept will be at 0. Now we put all the roots on the number line, and we're going to check the positive and negative sign for each interval. Since our leading coefficient is a +1, that means on the most right-hand side interval, it will be a positive. Then, look at all the roots. They all have an order of 1. That means they are all odd numbers. That means we are always interchanging the positive and negative sign. So it will be positive, negative, positive, negative. Now we are ready to do the sketch. First, put all the roots on. Next, we know has to go from positive region, go to negative region, go to positive region, go to negative region. And when they go through the roots, they all look like a linear function because they all have an order of 1. So let's do the sketch. So as you can see, when they go through the root, this part looks like a linear line. This part looks like a linear line, and this part looks like a linear line. And where they go through the y-axis, that's labeled then the y-intercept, 0. Part B. Once again, let's find the leading term. it will be negative x times by x times by x times by x. So it will be negative x to the exponent 4. Now, let's find the degree of the polynomial, which is the exponent of the leading term, which is a 4. Next, we're going to let y equal to 0 to find the roots. So we will get negative x equal to 0 means x equal to 0. X plus 1 equal to 0 means x could be negative 1. X minus 2 could be 0 means x could be 2. And x minus 3 could be 0 means x equals to 3. Now, look at all the factors here. They all have exponent of 1. That means all the roots, they all have order of 1. Then we let x equal to 0 to find the y-intercept, and we will find y-intercept is at 0. Now, let's put all the roots on the number line and check the positive negative sign for each interval. Since our leading coefficient is a negative 1, so we know the most right-hand side interval will be negative. Then we can see all the roots here, they all have an order of 1, which is our number. That means we are always interchanging. So the next interval will be positive, the next one will be negative, next one will be positive, next one will be negative. After we have the positive negative sign and the roots, now we are ready to do the sketch. So first, let's put all the roots on. Next, look at the positive negative sign and look at the order of the roots. Let's do a sketch. So we know all the roots here, they have order 1. That means when they go through the roots, they all look like a linear function. And where they go through the y-axis, that's labeled in 0. That's the y-intercept. Let's take a look at the root negative 1. This part looks like a linear function. This part looks like a linear function. This part looks like a linear function. And this part looks like a linear function. We also can use the degree of the polynomial to verify whether or not we actually got the correct graph. So since the degree of the polynomial here for part A is a 3, it's our number, that means on the opposite ends of the number line, it should have the opposite sign. So on the right-hand side is positive, on the left-hand side is negative. Now, for question part B, since the degree of the polynomial is an even number, which is a 4, that means on the right-hand side and on the left-hand side of the number line, they should have the same sign. So look at this. On the right-hand side is negative, on the left-hand side is negative. That means most likely we got the correct graph. For part C and part D, we're going to work on some polynomial functions that have a different order on the roots. Part C. Let's find our leading term. Our leading term is x squared times by x times by x, which is positive 1x to the exponent 4. So we know the degree of the polynomial will be 4. Then we let y equal to 0 to find the roots. So when x squared equals to 0 means x could be 0. Or when x minus 1 equals to 0 means x could be 1. Or when x plus 3 equals to 0 means x could be negative 3. Then we look at the order of the roots. In order to find the orders, we have to look at the exponents. So look at the exponents of all the roots. This is a 2. That's an invisible 1. That's another invisible 1. So we know the order of the roots will be 2, 1, 1. Then we let x equal to 0 to find the y-intercept. And we will get y-intercept is at 0. Now, let's put the roots on the number line, and we're going to check the positive negative sign for each interval. Since our leading coefficient is a positive 1, that means on the most right-hand side interval, it is positive. Then we go through the root 1. Because root 1 is order 1, that means we have to switch the sign, so it will be negative. Then we go through the root 0 to go to the next interval on the left. But 0 is an order 2 root. That means we have to keep the same sign. So the next interval will remain negative. Then we have to go through the root negative 3. But negative 3 is an order 1 root. That means we have to switch the sign. So the next interval will be positive. Now we are ready to do a sketch. First, we put the roots on. Second, we're going to draw each root first. So look at root negative 3. Because root negative 3 is order 1 root, that means when the function goes through it, it looks like a linear function, and it had to go from the positive region to go to the negative region, so it looks like this. Next, root 0. Root 0 is order 2 root, that means it looks like a parabola, but on both sides of 0 is negative, that means below the x-axis, so it looks like this. Next, at root 1 is a linear root because that's an order 1. That means the function goes through it looks like a linear line. That means it looks like this. Finally, we will connect all the pink lines and follow the positive negative sign of the chart. We can do a little sketch. Remember to label your y-intercept and use degree of the polynomial to double check. Since this is even degree, that means on two ends of the number line, they should have the same positive or negative signs. Let's move on to part D. First, we want to find our leading term. Our leading term will be negative x times by x times by x times by x squared, which will be negative x to the exponent 5. This means degree of the function will be 5. Then we let y equal to 0 to find the roots. So negative x equal to 0 means x equals to 0. Or x plus 1 equal to 0 means x could be negative 1. Or x minus 2 equals to 0 means x equals to 2. Or x plus 3 equals to 0 means x equals to negative 3. Then we look at the exponent to find out our order of the roots. So negative x has an exponent of 1, and x plus 1 to the exponent of 1, x minus 2 to the exponent of 1, and x plus 3 has exponent of 2. So we know the order at 0 is 1, and at negative 1 will be 1, and at 2 will be 1, and at negative 3 will be 2. Then we let x equal to 0 to find the y-intercept, and we will get y-intercept is at 0. Let's put the roots on the number line to check the positive and negative sign for each interval. Because our leading coefficient is a negative 1, that means on the most right-hand side interval will be negative. When we go to the root 2 has an order of 1, so we have to switch the sign. Then, when we go to the root 0, 0 has an order 1 as well, so we also switch the sign. Then, we go to the root negative 1. Negative 1 is also order of 1, which is odd, so we switch the sign again. Then we go to the root negative 3. But negative 3 has an order of 2, which is even, so we keep the same sign. Now we are ready to sketch. First, put all the roots on. Next, we're going to graph every single root according to their order. So starting with the most right-hand side, positive 2. Now we are ready to sketch. First, let's put all the roots on. Next, let's graph all the roots with their order. So at 2, it is a linear root, and they go from negative region to the positive region. So we will draw a line like this. Next one, root 0, which is order 1, which is another linear root, and they go from positive region to negative region. Now we are ready to sketch. First, put all the roots on. Then, we're going to graph all the roots according to their order. So first root at 2. This 2 is an order 1 root. That means it looks like a linear function. Now, we are ready to sketch. First, let's put all the roots on the graph. Next, let's graph all the roots according to their order and the positive and negative sign. So at root 2, root 2 is an order 1 root. That means the function goes through it like a linear relation and has to go from negative region to the positive region. So it looks like this. Next one, root 0 is also an order 1 root, and it goes from positive region to negative region. And next one, at root negative 1. Negative 1 is order 1 root. That means the function goes through it, looks like a linear relation as well. But this time, it goes from negative region to positive region. And the last one is negative 3. Negative 3 is order 2. That means it looks like a parabola when the function goes through it. And it has to go from positive to positive. So it looks like this. Now, we're going to connect all the pink lines and follow the sign on the number line to graph a sketch. Remember to label the y-intercept and use our degree of the polynomial to double check. Since the degree is a 5, it's an odd number, that means on the two ends of the number line, they should have opposite signs. Example number 3. First, let's find our leading term. Our leading term will be 2x holding square times by x to the exponent 3 times by x, which will be 4x squared times by x cubed times by x, which will be positive 4 x to the exponent 6. So our degree of the polynomial will be 6. Next, let's find our roots. That means 2x minus 1 will be 0, means x equals a half. Or x plus 3 equals 0 means x equals negative 3. Or x minus 2 equals 0 means x equals 2. Then we have to find the order of the roots by looking at exponents. So the first root has exponent of 2, so we say order is 2. The next one, exponent, has a 3, so we say the order is 3. And the last one, the exponent is an invisible 1, so we say the order is 1. Next, we have to find our y-intercept. We let x equals 0, then we get 0 minus 1 squared times by 0 plus 3 to the exponent 3 times by 0 minus 2 to the exponent 1. Then we will get 1 times by 27 times by negative 2, which will be negative 54. Let's put all the roots on the number line, and we're going to find the positive negative sign for each interval. So on the most right-hand side interval, we can see the leading coefficient is a positive 4, so the most right-hand side will be positive. When we go through the root 2, because the root has an order 1, that means it's odd, so we switch the sign. When we go through the root half is order 2, that means we have to keep the same sign. That means we keep negative. Then we go to the root negative 3. Negative 3 has an order 3, which is odd, so we switch the sign, which will be positive. Now we are ready to sketch the graph. So first, put all the roots on the graph. Then we're going to graph each root first. So we know the root 2 is order 1 and go from positive to negative region. So we will do this way, like a linear relation. Next one, at the root half, it is a parabola, and on both sides is negative, so it looks like this. Next one, at root negative 3, that's a degree 3, that means it looks like a cubic function, and it goes from negative region to positive region, so it looks like this. Let's connect all the pink lines to make a sketch. Remember to label the y-intercept at where they cross over the y-axis. Finally, let's use the degree of the polynomial to verify whether or not we got the correct graph. Since the degree is an even number, that means at the two ends of the graph, they need to have the same sign, which we do have. Therefore, this is a sketch for the polynomial function that we have here.